Alright, so again, this is the distance of 1 light year in units that are much more familiar, kilometers and miles, of course. Alright. Alright, so just keep this in mind. We're of course, part of the solar system, the Earth, of course, which is the solar system, our sun and associated planets and asteroids and comets and things like that are part of the Milky Way galaxy, which is a part of what's called the local group. It's just a small group of galaxies, and that the local group is part of a much larger thing called the supercluster. Our supercluster, our local supercluster, happens to be called the Virgo supercluster, because it's in the direction of the constellation Virgo. All right. So, and then, of course, everything originally came from the Big Bang, an event that happened 13.8 billion years ago. The Big Bang itself created hydrogen and helium, and then the hydrogen is turned into helium in stars, and then towards the end of their life cycle, they turn the helium into heavier elements. Really massive stars turn the elements into it turn into even heavier elements, heavier than iron. Low mass stars turn out they can only turn the helium eventually into iron, but the really massive stars during their supernova explosion can create the rest of the periodic table. All right, so and then the further we look in space, the further back in time. We can only see roughly 13 billion, 13 and a half, or 13.8, I should say, billion light years, actually less than that, in one direction, or 180 degrees from that. But we certainly think that there is galaxies further than that. It's just that the universe is not old enough for the light from those galaxies. Let's say there's a galaxy 20 billion light years away. Well, the universe is simply not old enough for us to see that in our telescopes, because if it's 20 billion light years away, it would take 20 billion years, which that is not the current age of the universe. Until the universe is that old, we won't see those galaxies. Let me talk about scientific theory. I briefly mentioned about this in the first video for chapter 1. So the big thing that distinguishes the current science from what the Greeks did. The Greeks certainly thought about the universe and thought about how things work, and even came up with models and things like that. Like, for example, the geocentric model, which is the Earth is the center of the universe, which of course turns out to be wrong. The thing that is really in the modern scientific method is this idea of something being testable, right? That you have to be able to. You have to be able to perform an experiment that will verify scientific ideas to be true, or that really more than likely. And what usually happens with science is you have to modify. You don't just sometimes you just have to completely abandon a theory, but more than likely you're modifying it. And all right. So let's move on. So this is the general steps in the scientific method. Is you see something in nature, you form an idea that explains it. Sometimes that's called a theory, and then if using your explanation or your theory, you come up with a prediction, and then of course you have to perform an experiment that proves whether the prediction has come true or not. All right, so moving on, when we look out, oh, there's a nice. This is actually the constellation Orion right here. There's the belt of Orion. This is this kind of orangish star is called Betelgeuse. This bright star over here is called Rigel. This is the Orion Nebula right here. So this is actually a little beyond what the human eye can see with unaided. This is like a binocular view. So when we look out into the night sky, there are these patterns, and they've been around a long time. And the pattern, like for example, these three stars that form the belt, that doesn't change over time. The Greeks looked up, the Chinese astronomers all over the planet looked up, thousands upon thousands of years ago, and saw this exact same pattern. And now the pattern moves across the sky. Every single night it moves, but it moves in a very in exactly the same way, night after night after night. Without the use of the telescope, you can see about roughly 3,000 stars. And those patterns they're really just regions of the sky, just areas of the sky. There are various shapes. The Greeks saw a hunter here. There's like Orion's supposed to be raising a sword, which is over here. It doesn't, the pattern itself doesn't matter. It's just a region of the sky. It's kind of like the United States, right? The United States is broken up into these 50 states where, sometimes the borders between the states are just artificial, right? There's just these artificial. I mean, sometimes there's actual physical boundaries like rivers and mountains and so forth. But in the night sky, these regions are just broken up into really what the brighter stars form these patterns that we call the constellations. There's 88 of them, a total of 88 constellations across the sky. So there's a nice picture that shows Orion. There's the belt, the three stars of the belt, and there's this star is called Rigel. This one's called Betelgeuse. It doesn't really matter. This one over here is called Bellatrix. Not that matters. All right. Yeah, so that's those are what the constellations are. There is if you're in the northern hemisphere, which if you're at York Tech, more than likely you're in the northern hemisphere. There's a very special star in the direction of called the North Star, or Polaris is its technical name. And what's special about that is here. Let's see. As I mentioned before, the constellations move across the sky, but Polaris remains in the same position. It's actually not exactly at if you projected the North Pole out into space, and just imagine a line going from the North Pole out into space, Polaris is really close to that. It's within about a degree or so of that. So it doesn't really move very noticeably, over as the night goes on and on. There's not a similar bright star in the southern, at the southern celestial pole. If you just projected the South Pole out into space, there's not a really bright star there, and so Polaris is certainly not the brightest star in the night sky, but it's relatively bright, compared to the other stars. All right, so this is just showing some different constellations. Here's Sirius. This is actually the brightest star in the night sky. It's not the brightest star of all the stars. This just happens to be the brightest star that we can see. Of course, more distant stars can be way brighter than Sirius. That just happens to be the brightest star that that we can see. Different stars have different what they call intrinsic brightnesses. All right, that's kind of getting away from what we need to concentrate on. Again, there are 88 various shapes across the night sky called constellations. So generally, like if something happens in Orion, for example, if there's a meteor shower that comes out of from this direction, from the direction of Orion, that's then that meteor shower would get that particular name. Like, for example, in the summer, this isn't showing this particular constellation. There's a really nice meteor shower. It's in mid-August, called the Perseid meteor shower. So that is in the direction of the constellation Perseus. All right, just to let you know. So the stars are, from our view from the Earth, of course. The stars all appear, as though they're in the same distance, but they're vastly different distances from us. Some of them are much closer, some of them are much further, and the close ones might be just inherently or intrinsically dim, and much further ones might be even brighter to us in the night sky, but they're just brighter stars. They're usually much larger. For example, will generate more light. All right. Let's see. So the brightest stars in a constellation, can actually be C is actually the right answer. Can actually be very far from each other. They don't have to be in the same. If you look at all the stars in the constellation Orion, they're vastly different distances from each other. It's just, from our point of view, they happen to look in the same region of the sky. All right? And of course, we're just seeing this on a two-dimensional layer. And actually, if you imagine a sphere around the Earth, where the stars are, this is just a model, by the way. This is called the celestial sphere, and here's some different constellations: the constellation Gemini, Orion, Sagittarius, and Virgo. I mean, the Cassiopeia. The Big Dipper actually is not a constellation unto itself. It's a smaller part of a constellation. When you actually have a part of a constellation that has its own name, like the Big Dipper or the Little Dipper, that's called an asterism. Just to let you know. All right, and just like the Earth, we break up the Earth into latitude and longitude. This spherical object called the Earth. The celestial sphere is broken up into similar names. Well, then actually the names aren't similar, but similar ideas of latitude and longitude. But they're called right ascension and declination. All right, so. This is the ecliptic, by the way. Just since this name has come up, that's actually the path that the sun takes across the sky, and the Earth is actually tilted with respect to the path that the sun takes over the course of a year by 23.5 degrees. In other words, our Earth, the poles. The Earth's pole is tilted by 23.5 degrees, which is actually the reason for seasons on the Earth. It's not because we get closer to the sun or further from the sun, which we do, but that's not the cause of the seasons. All right, so as I said, there's 88 constellations. Let's see, we're almost. So, as the Earth goes around the sun, we see different constellations in the night sky. If you any given night, you can go out and you can see a particular constellation. Let's say, if you're looking, let's say, towards the western sky, over the course of a year, those constellations will basically will move towards the west, and you won't be able to see them, because it's still sunlight. So it takes some time, at least a month or so to go by. But then you won't see them in the evening sky. You'll only see them in the morning. All right, I'm gonna stop this video for now and move on to the next one.